today is today's lesson is really nothing new. We've actually already done it all. So, and we did it at a time when you might not have thought of it as, well, you remember that when we talked about, what are they? Frequency tables. We made frequency tables, how often something occurs. We made histograms, and it might not really have seemed like we were doing all that important stuff with statistics, but what today we're going to do is we're going to do that same stuff, but we're going to give it different names, different vocabulary, and you'll see that you were actually doing something that leads you right into statistics. That is actually statistics. So it's like that the Karate Kid wanting to learn karate thinks he's just waxing the car. He's actually building the muscles and the strength and the knowledge to do karate. Unfortunately, I can't teach you karate, but I'll teach you how to do statistics from what we've already done. The other thing I'm going to do is I got looking over scores and such as an because what we did before is going to relate to what we're doing next. It's good to finish up anything that you haven't gotten done from the start of class. And so to give you a little incentive, you can get those things done at 80%. So you don't have to get 100% on everything. Get 80% on everything. You will earn 100% on those. It makes sense? So if you haven't started an assignment, it's in the past, I forget about it, go back and do it. If you get it to at least 80%, you'll get 100% on it. Now you say, well, wait, that's not fair. I already got 100%. You've got 100% on it. I'm going to give you 5% extra credit. Now, because it's homework only counts for 30%, it's actually like, it's not that much. It's like 1.5%. And that's about what at college level, we're limited to the amount of extra credit we can give, but it's about 1.52%. So that's what you would be getting. So if you've already got them done, or if you get them done at 100%, say by Thursday, I'll bump them all to 100%. And the reason is I want you to, whatever we've already learned is going to be beneficial for you as we go forward. If you don't do that, you're going to struggle a little bit. You might learn it in the new setting, but it'll set you up really well for success if you can finish up the reading quizzes, the homework quizzes, because the homework quizzes are just the homework again, a shorter homework version, but it just reinforces what you've learned. Okay, and you can do it by this Thursday. I'll take a look at everything, and again, if you've already got 100, if you've got 100%, if you've already had 100%, you'll get that extra 5% on the homework. And if you just get it, you say, let me just do 80% of it. That's still worthwhile. You'll get the full value for it. Make sense? Any questions? Okay, good. So let's go ahead. So now we're diving into chapter 5, discrete probability distributions. And as we go through this, if you can have your calculators ready, whether you have it on your phone, and I've got an extra one here. Would anyone like to use a real one with the buttons? All right. Thank you. Give it a try. Have your computers ready, because what I want you to see is what we're doing, again, is not really anything new, but what I am going to show you how to do something that's a little new is how to use the calculator to do these distributions, to do the calculations for us. And it's really going to pay off as we get deeper into these different ones. Okay, so probability distributions. So what I want you to think right now is when we did, let's see if we can remember, we did frequency tables, right? Frequency tables had values like test scores, right? And then what was the frequency? What did the frequency represent? So I'll say I got a score of 70 and I had a frequency of 5. What does that 5 mean about the score of 70? It could be. We'd have to see the rest of the data, so it could be unusual. It might be usual, But what does that 5 represent? 5 what? Amount of data. 5 people got a 70. That's all that's what a frequency is. And then what else did we do with that frequency of, say, 5? We also wanted to know something about that frequency. We did another calculation. Was that? We did the cumulative too. So we won't focus on, but that's another thing where we kind of, from the beginning to go, what else along with the cumulative did we do? We called it, started with an R, relative frequency, which was a percentage. We're going to do that same thing, except instead of calling it relative frequency, we're going to call it a probability. Okay, so we're just kind of changing the name, but we're doing the same thing. So if you kind of, as we go through this, you'll hopefully it'll remind, oh yeah, we already did all this stuff, and you'll see how that works. Okay, so that's all the distribution is. It's a frequency table. The numbers represent how many times that score was achieved. We're going to get a relative frequency, which then we turn and say, well, that's really a probability. It's the probability of that score coming up. And then we're going to make a histogram. Okay, so the first thing we're going to introduce is something called a random variable. What I want you to see, it's really nothing new. I remember when I took this at the graduate level, this stuff scared me. What's a random variable? Got this X and stuff. But what a random variable is, it's a numerical value associated with each outcome of a probability distribution. Fancy words, right? That score of 70, that's a random variable, the score. If we had dice, then the random variable would be 1, 2, 3, 4, 5, 6. So there's 6 different random variables. So we just say x equals 1, x equals 2, x equals 3. What I want you to see is we've done this, right? We calculate the probability of getting a 3, 1, 6, because there's 1, 3 out of 6, right? We've done that. We're just using some different vocabulary. Now we're going to call getting x equals 3 a random variable, which just means we rolled a 3. Okay, so it's just sort of new vocabulary, and don't let it scare you like it scared me for years until that actually, just to be honest with you, it wasn't until I started teaching this that I really said, oh, random variables is not a big deal. Before I thought they were a big deal because that's the way it was presented to me. But what we can also do with the random variable x, it could represent a lot of different things, like the number of sales call a salesperson makes in a day. So someone's trying to sell stuff, they call. And I used to be in insurance, so I was a person, you make 100 calls, and if you get 10 people who said at least would listen to you, you were doing good. Actually, yeah, you make 100 calls. Sometimes if one person didn't hang up on you, that was a good day out of 100 calls. But that could be a random variable, how many calls somebody makes. It could also be the hours that the person spent on the call. So you see, we set the random variable to tell us what's important. How many hours they spent, that might be how they got paid. Okay, so they called for 5 hours, they made $15 an hour, we can calculate how. Or they might get paid by how many calls they make. So that could be a random variable. Does that make sense? It becomes a random variable if we assign it a number. Can you see with these two types, we have 2 different levels of measurement? Remember those kind of concepts, right? If you're counting the number of calls you make, what kind of numbers can you get? Can you get like 2.5 calls? No. Started dialing it, but you didn't finish. No, that doesn't count. You either get 2 calls or you get 3 calls, right? You can't get 2.5. And what we do is, again, more vocabulary, we call that a discrete random variable. You either get 2 or 3, but not 2.5, not 2.25, just whole number values. Okay, so that is a discrete. Now with discrete, you can actually also get negative values. So it's not like interval and ratio level type stuff. But what this is you can only get basically whole number values, integer values. Make sense? Okay, and it happens a lot if we're counting how many fish we caught. You can't catch half a fish. You can't catch a quarter of a fish. You catch either 2 or 3 fish or 4 fish or 5 fish, right? But if you're counting the hours that the sales calls were made, right? Could you get 2.5 hours? Sure. 2.25 hours? 2 hours and 1 minute? Sure. So those are called continuous random variables. And as you see here on the number line, it can take on any values in between. Okay, so those are the two different types of variables we work with, discrete and continuous. And we're going to see the mathematics we do is going to be different with both of them. Today we're going to, in fact, I think all this week, we're going to focus on just the discrete ones. They're a little easier to work with in some ways. So we're going to focus on discrete, okay, which are these ones back here, right? 1, 2, 3, 4, 5. So those would be our random variables, just how many times something happens. But what we get to for the next one, we start looking at those continuous values, and the math changes a little bit. Okay, sure we're on track. So just a couple examples. I want you to think about these, and if you can, let's go ahead and say whether this is discrete or continuous. If X represents the number of Fortune 500 companies that lost money in the previous year, is that going to be discrete or is that going to be continuous? What do you think? Discrete, why? Out of those 500, because could you have 2.5 companies that lost money? No, either 2 companies lost money or 3 companies, right? So think about that. Now there could be some that broke even, but this is on, they either lose money or you don't, right? And so this is definitely a discrete. It's a number, could be all the way up to 5. Maybe they all lost money, but you can't get those in between values. Make sense? Okay, so just kind of, this gets back to that, all that stuff we did with those 4 level of measurements, which may have seemed kind of, well, why are you even talking about that, right? Because it becomes important here. How about this one? If X represents the volume of gas in a 21-gallon tank of, like in your car, is that going to be discrete or continuous? Discrete, why? Sure. Continuous, right? Because gas can get used up, right? You can get down, you could have 2.5 gallons left. You could have 2.25. So yeah, so gas gets used up that way. When you're counting gallons, it's not just going to jump from 1 gallon to the next, anything in between. Okay, so this one is continuous. Again, so it's not something we're going to look at today, but continuous variables. Okay, so just think of that. If you walk, if you pick up your feet and you step, that's like discrete, right? I'm taking a step. If you slide your feet, that's continuous, right? Your feet never leave the ground. So just think of that continuous is going to be a variable that can basically, it could be just any value along that number line. Where discrete, you have to pick up your pen and go to the next step. Okay. All right. So for all of this, now all this is just kind of building up. To get a discrete probability distribution, let's think about probabilities. For something to be a probability, and we look at its sample space, what was the largest value we could get for a probability? Do you remember that? 100%. Very good. 1 or 100%. 1 is equal to 100%. What's the smallest probability there could be? We have negative probabilities? No? So what's the smallest number a probability could be? 0. That means it's impossible, right? So we go from 0 to 1, and so that's the same thing with a probability distribution. Each probability has to be a number between 0 and 1, but more also, for all of the probabilities together, they have to add exactly to 1. They can't be less, because if we only got 90%, we haven't got everything. So probability distribution has to be the total probabilities. They have to add to 100%, or again, if we're using decimals, they would add to 1. Does that make sense? Again, nothing new. We talked about this in probability, but now we're just putting probability and frequency distributions together in sort of one concept. All right. So now let's go ahead and do this. And I want you to see, you've probably already done this. How do we make a probability distribution? Well, we have to start with a frequency table. So this is a test for passive-aggressive trait. Do you know what passive-aggressive is? Kind of. It's when people are, they kind of, I guess sometimes I'm a little passive-aggressive, is you're not really going after them, but you make a little comment or something, or you do something that's kind of aggressive, but you look like you're not really doing it. Something like that. I try not to be that way, but I don't like to be really aggressive, so sometimes I am passive-aggressive. Okay, so they gave this test 150 employees, and they were scored from 1 to 5, with 1 being extremely passive and 5 being extremely aggressive. So passive is, you try not to say too much, you hold back. And then 3 is kind of in the middle. They're not really aggressive or passive. Okay. So that's what the random variable is. That's the first thing you have to do. What is our random variable? In this case, it's a score on a test from 1 to 5. So we've got those listed here, 1, 2, 3, 4, 5. We've got the frequencies, so we've got the data. How much does all these frequencies need to add up to? We're looking up here, right? We gave it to 150. So hopefully these all add up to 150. And that's one of the first things you want to check, that we've got all the data. Okay, so then to construct a probability distribution, and we did this before, what we do is, we didn't call it probability distribution, we called it, what kind of a frequency? Relative frequency. So we're going to do the same thing. How do we calculate a random or a relative frequency? Percent frequency. We take each number, and what do we do to it? Well, we add them all up to see that there's a total, right? Good. And then we divide it by that total. Exactly. So the 124, we're going to divide by 150. And again, that's why you've got your calculators out. If you could start working on this, I'm just going to write these down, and then we'll come up with these. 33 divided by 150. 42 divided by 150. 30 divided by 150. And 21 divided by 150. So these are the calculations. And what it's going to give us is the probability of that score. Okay. Has anyone got the 24 divided by 150? 0.16. How about 33 divided by 150? 0.22. 42 divided by 1? 28. Okay. 30 divided by 150. And then 21 divided by 150. 42? No, 14. Okay. And what does this all have to add to? 1. 100%. Yeah, so if we're thinking of it in percents, 100%, or it has to add to 1. Let's see real quickly. There's 10. There's 10. That's 20. Carry the 2, 3, 4, 5, 6, 7, 8, 9, 10. It all adds up to 1. Good. So that tells us, yeah, it's going to, and when we do it this way, they always will, right? Because we divided by the total. So they should all add up there. We have a probability distribution. And basically, this here is a probability distribution. Each one of those numbers is between 0 and 1, and the total is equal to 1. not between, right? The total has to be everything. So this is what we came up with, right? And what we called this before was a relative frequency. Now we're just calling it a probability. Okay? It was a percentage. It's still a percentage. Probabilities are still percentages. And it fits the definition. Each one is between 1, and when you add them up, you get 1. Okay? Simple. And again, nothing really new. We did this before when we were doing frequency distributions. So again, if you hadn't finished that one up, that would be a good one to finish up. And this week you can earn back those points, right? And you only have to get 80% of the homework done to get all the value. Or if you do get 100%, you get an extra kick, which extra credit's always nice. Okay, this is the list of what we just did. So usually they give you, this is what you're gonna, we did this, didn't we? Make a frequency distribution. They gave that to us. We found the sum of the frequencies, 150. We calculated the probability of each one by dividing, and then we checked that each one was between 0 and 1 and that the total was 1. So we did all of this. So if you understood that, but here's a list in case you want to go back and have sort of a checklist of what you do. It's here. We could then make a frequency, or what do we call this? Histogram, right? So the scores of 1, 2, 3, 4, 5, and each of their frequencies. Again, we could have had frequency numbers, but these we had relative frequencies. Okay, and this is going to help us as we move into continuous, because these are a little easier to understand, right? Scores either going to be 1, 2, or 3. Can you look at this, just the chart, and see what would be about the average score on here? The middle, the mean, the median, the mode. Which number would be that? 3, right? It's the one that occurs the most. It's also in the middle there. So if you went to get the median, it'll be there. We're going to do a calculation of the mean itself, and we'll see we're very close to 3. It is slightly skewed. You can see this bar is not equal, so it's not completely symmetric, but it's pretty close. Okay. So far, are we feeling comfortable about frequency? Okay. Probability distribution is really just a frequency distribution. We did this, right? We're just using different words to explain it. And we'll use it in different ways. We'll see how that works out. Okay. So here's another one. We want to verify, is this a frequency, or is it a probability distribution? And this is verify the distribution for the 3-day forecast and the number of days of rain is a probability distribution. I'm going to give you just a moment. What are the 2 things we have to check? Make sure it's a probability distribution. It adds all the way to 1, and that each one of these individually is between 0 and 1, right? Can't have negatives, can't have over 1. So how about that first one? Are each of them between 0 and 1? Yeah, so these are, the variable isn't, right? Variable is 0 days of rain, 1 day of rain, 2 days of rain, 3 days of rain. Now we got to see, do they add up to 100% or to 1? They do? Okay, so we'd add them up, and indeed they did. Add them all up and you get 1. So it's a probability distribution. We can use it as a probability distribution. Okay, some of the questions they may just ask you is, it is. How about this one? Does it satisfy the first one? Is each value, is each frequency between 0 and 1? Yes. Does it add to 1? I don't need this much today, do I? It doesn't. It adds to what? 1.07. And so it's like 7% above. It's not a probability distribution. We can't use this as a probability distribution. It's something else. It is relative frequencies maybe, but whatever this is, it's not a probability distribution. We can't use it for the type of stuff we're going to do. It has to equal exactly 1. What if it would have been equal to 0.97? Would it? No, still not. It has to equal exactly 1. 0.97 is missing something, so we can't use it either. This has too much, so we can't use it. So it has to be exactly 1. And some of the homework you'll look at, they'll ask you, is this probability distribution or not? You just got to make sure it fits those two things. Now we're going to go about finding the mean of a probability distribution. And you're going to see it's in notation, it's the variable, the x variable, times its probability. Okay. You add all of those together. And now remember when we took the mean, we added everything together, and then what did we do? So we had 5 numbers. We added all 5 numbers together and then divided by 5, right? Right. This time we're not dividing by 5, but think of what we've got. How did we get that relative frequency? By dividing. We've already, this has, when we're dealing with a probability distribution, we've already done the division for each one individually. So that's why we define the mean, we don't actually divide. Okay. So I'm going to show you, well, let's do this one sort of by hand, and then I'm going to show you how you can use your calculator to do this, so that like when you're doing the homework, maybe just use the calculator. But what we're going to do here to get the mean, what we're going to do in its calculation is we're going to take 1 times 0.16. That one's an easy one. I always love to multiply by 1. Then we're going to take 2 times 0.22. And can you, those want to follow along with your calculators, could you help me out with these? 3 times 0.28, 4 times 0.20, and 5 times 0.14. What's this one? 4. This one, 787. 4 times 0.2, 0.8. 5 times 0.14. How much? 0.7. Thank you. Okay. Now, these are going to add to more than 1, aren't they? Yes, sir. 8.4. Thank you. Good. That's because this is important, right? Otherwise, we'd be off. Good. Thank you for checking. We have to add all these together, and what do we get? There's 10, 14, 21. Oh, no, 14. I think, let's see, 10 and 4. 1, 2, 6, 14, 22, 29. About 2.94. Is that what you got? Anyone? How long did we go till? We are 9:55. Okay, good. That correct? Yes? Okay, good. What does this 2.94, what does that mean? It is the mean, but what does that mean? Not quite. What is this number? This actually, these are no longer percentages. These numbers are percentages, but we're multiplying them by the random variables, right? And what are the random variables? They're scores on that test from 1 to 5. So this is a sort of a weighted mean. This number is what? It's not a percentage, it's a score. It's a score that's close to what number? 3, right? Because we already talked, this is not, discrete. You can't really be, no one got a score of 2.94, but the average ended up being close to 3. And on our scale, do you remember between passive and aggressive, what did 3 represent? A little bit of both, or a little bit of, right in the middle. So neither passive nor aggressive. So that's what it's saying. On average, the average score is people right there in the middle, not at the extremes of being either passive or aggressive. At an average, we're there. What I want to do is, let's see if I want to show you how you can use your calculators to calculate the same value, because before we get into the next one, let's see, let's keep everything here. Let's get that out of the way. Okay, so on your calculators, what we're going to do is we're going to see we can use the statistics functions we've always been using. So we go down to statistics. I'm going to hit OK. In my data, now, if you go on yours and you've got, if you want to watch, that's fine. But if you got data here, you could go to the clear button here and enter. Oops, maybe because there's nothing there. But you want it cleared out. What we're going to put in value 1 is the random variable 1. What we're going to put for the frequency is 0.16. Does that kind of make sense? So the frequency is becoming the relative frequency, which is becoming the probability. Random variable of 2, a score of 2, has a probability of 0.22. Put that in. Random variable of 3 has a probability of 0.28. And the random variable 4 has a probability of 0.2. Now notice it kind of enters a 1 for us, so you just got to make sure you get all these entered in correctly. Arrow over, we want 0.14. So that's our probability distribution. The cool part about this is we could graph this, right, if we needed to. Let's go to graph. We want to do a histogram. And these are now, it's a relative frequency. That kind of looks like what we had on that one slide, right? But the other thing we can do with this is we can come up here and we can do stats. And notice it's made all these calculations for us. What are we looking for? We're looking for the mean, right? 2.94. So look at it, it will do the mean for us. So on your homework, you've got these probability distributions. If you enter them this way and you're asked to find the mean, you could do it this way. But just remember, what you're doing is you're taking each random variable times its probability. That's what this is doing. And when you enter it in, you're kind of going to see it. But what's really cool is remember, we did also something called a standard deviation, right? The mean has a standard deviation, which tells us how spread out it is. That was a painful thing to do, wasn't it? Because you had to take the mean and subtract it from each one. You had to square it. You had to do a lot of things, but watch what this will do. Standard deviation is 1.27. And we're going to walk through the calculation for it as well, but I want you to see is if you do it this way, you'll get your standard deviation as well. Because in the homework, there's going to be some problems that ask you to find the mean and standard deviation. If you enter it in, you're going to get them both right here. Now, there is also, well, actually, what you'll see is how do I tell the difference? Remember, there's a sample standard deviation and a population standard deviation. Well, the sample standard deviation doesn't exist because remember, the total was 1. 100% adds to 1. If you take 1 minus 1, what do you get? 0. If you divide by 0, what do you get? Infinity, actually. So that's what's happening. We don't have to worry. It's going to be the population standard deviation. So when we're dealing with a probability distribution, the idea is we're dealing with a population. Okay, but we got our mean and our standard deviation right there. So the last part of this lesson is I'm going to show you how to calculate the standard deviation. But if you use your calculators, you'll already know how to do it. Okay, but we want to go through the process so you understand, yeah, the standard deviation is just basically subtracting off the mean from each one and going forward. But to actually do it, just put it in the calculator. Remember how to do that. And the reason because it's on your, you've got it on your cell phone now, you've got it with you any place you need it, you can do this. And if we're able to obtain the hard calculators, and maybe you're able to keep them, you'll always be able to do this in any class. So that one, yeah, actually it had it all there. If you watch the slides, they do all the work, but I wanted us to do it. So here's the formula for getting, remember, we calculate the variance first, then we take its square root and we get the standard deviation. The number we're interested in, though, is just the standard deviation. So notice what's happening up here is that, oops, click too far. This. Is we had to find the mean first, and then you take each value and subtract the mean, you square it, and then you multiply it by the probability for each one. And then you do that, and we've got 5 random variables, right? So we got to do this 5 times. And then at the end, we add it all together, and then we take its square root to get that number 1.27. I'm going to take an easier approach to this. We're going to say, okay, here it is. We found the mean was 2.97 or 2.94, sorry. You subtract that from each piece of data, you get a new number. Notice some are negative, and actually if we were to add these together right now, we would get 0. But we don't do that. That's why we square it, remembering how the standard deviation works. Then we multiply it by its probability. That is like doing the division that we would have done, dividing by n or n minus 1. And then you add it all together, you got 1.61. When we take the square root of that, what do you think we're going to get? Does anyone remember what the standard deviation was from the calculator? 1.27, right? Okay, 1.27 or 3, about 1.3. And remember what that is. That gives us sort of what we found is the average is about 3, right? 2.94. It's about 3 with a standard deviation of about 1.3 above, 1.3 below. So the average score, what we could say is on average, people scored about a 3 in the middle, but the average spread is 1 below to 1 above. So 2 to 4, makes sense. And then, at the far ends, that's maybe less usual. Make sense? Okay. Again, I'm not so interested that you go through this process, but if you can at least view it and understand it, what's going on, then this number that you get will make sense. But for doing the homework to actually calculate it, whenever you're doing statistics, you're going to want a calculator to go through all this because there's a lot of places you can make errors, right? And if there's that many places, I'll guarantee you, I'll probably make an error somewhere along the line. And I'll get this a little bit off. So again, for all these calculations, understand how the calculation's done, understand what you're getting, you're finding the middle, and then this, the standard deviation, is giving you your spread, how far from the middle on average is data. Okay. The nice part is there's something called, the reason we do all this with probabilities, we're trying to get at an expected value. I better hurry up a little bit. This is nothing new. All this is telling us is when we found the mean, that's also the expected value. Now we're going to see on some of the, we're going to look at different types of distributions. And that isn't always the case, but with a discrete probability distribution, the mean is also the expected value. And what the expected value gives us is it gives us the value we would expect to get if it was done a large number of times, okay, on average. So it's an average. That's what it is, a mean, right? So we're going to go through an example together. And we're going to build this, and we're going to understand that once we've got the mean, we've got the expected value, and then what that might mean. So we're going to take, and this is our last thing to look at, so we'll be able to get here. So we've got a raffle of 1,500 tickets sold at $2 each. They're trying to raise some money. They give out 4 prizes: $500, $250, $150, and $75. If you buy one ticket, find the expected value and interpret its meaning. Okay, so first of all, we've got to determine what is the random variable. Well, you might think it's the winnings, but if you won the $500, how much do you actually take home with you? How much did you actually win? Because to win, what did you have to do first? You had to buy a ticket. You had to take $2 out of your pocket, and then they give you $500 back. So what's the net result to you? You paid out $2, you won $500. Does it make sense that the net value is you actually really only won $498 because you got your $2 back, but that's not really winnings. So that's what happens with each of these. So 250 minus 2 is 248. Make sure I do this right. 150 minus 2 will be 148. And then 75 minus 2 is going to be, thank you. But there's one more. If you didn't win anything, what did you win? You lost $2, right? You paid. It's going to charity, probably something nice, but you walked out with $2 less. Okay, so we've got, this is all our random variables. These are all the things that could happen from our perspective. What's the probability of winning $498? How many tickets are going to win that much? You ever been to a raffle? How many tickets are they going to pull for this $500 prize? One, because there's only one prize, right? So that's going to be 1 out of 1,500. Make sense? That's its probability. How about to win 248? One person. So it's kind of boring, but it is. They each have the same probability. Does that make sense? Now, what's your probability of losing? There's 4 that won, so 1,500 minus 4, right? You have to calculate this. So out of 1,500, there's going to be 1,496 losers or donors. Their money went there. Okay, makes sense so far? So those are a relative frequency if we want to think about it. That's all it is. It's a probability. And then what we do is we're going to multiply each of these. So take 498 times 115. Went over, so each of these get multiplied. These are going to be pretty small numbers here, except for this one. But what I want to show you is when we go to calculate these, we can use our calculator here. So what I'm going to do is I'm going to go back up to data. I want to clear these out. Yeah, I want to clear these out. I'll hit this clear button, this back X, and yeah, I want to clear everything out. Confirm. Oh, I have to go that way. It's not a touchscreen. Okay, so then we put in our random variables, 498. We put in its probability, 1 divided by 1,500. And when I hit enter, I get this weird number. It's a number it's like a 0.000 something, right? It's -4 is a power of 10, so move the decimal place back over 4 places. And we're going to do this for each of these. So put in 248. Oops, not there. 248 here, and 1 divided by 1500. 148. And then we're going to 1 divided by 1500. 73. 1 divided by 1500. And the last one, -2. And that was 1496 divided by 1500. Okay. Expected value is just the mean. So we go up, go to stats, we go down to the mean. The expected value is you will lose $1.35, right? -135. What that also means is that the people who are running the raffle, they expect to win 135 on each person. So they're paying out some prize money, but they will win in the long run. So that's what it gives us. And what I want you to see is we'll do one more. These are all the calculations we did. And so on average, each person loses $1.35. Now, again, in reality, you lose $2, but this is what a expected value gets us to think on average what's going to happen. So then you could say, okay, take 1,500 times 135. That's how much that charity is going to win, which is about $2,000. So even though they're paying out some money, they're getting more money to come in if they can sell all their tickets. Make sense? All right. So what are you going to be doing this week? If you haven't finished up past homeworks, you want to get them to at least what? 80%. At least there. You get them to 100, what do you get? An extra 5 points. 5% on it. Good. So there's some incentive to get those things done this week and keep moving forward. And the homework shouldn't be too bad because it's really just relative frequency charts like we were doing, and work through those. Okay. So we'll pick this up with some more on Tuesday. Thank you.